In the second event, sphere 2 kg collides head-on elastical with sphere 4 kg at t equals 0. And that particular thing they're plotting. So which is event 1 and which is event 2. So again, we are going back to the basics of the collision, nothing big. So first event will take it. What actually happens in first event? So there's a 1 kg block. This is advanced question asked in advance. And this is 2 kg at rest. No? They'll collide and at maximum compression, at maximum deformation, both will have common velocity. So V1, call V1. Can we calculate that? V1. So what is the initial momentum? 4. This should be equal to 1 plus 2 into V1. So what is V1 equal to? 4 by 3 meter per second. From here to here is what? Impulse of deformation will act. No? Impulse of deformation. Can we calculate that JD, impulse of deformation? You take any one block. Let me take 1 kg ball. 1 into 4 minus JD should be equal to 1 into V1. So 4 minus JD equal to 4 by 3. So what is JD1 we'll call it, because there's impulse in the first event. 4 minus 4 by 4. So 12, 8 by 3 Newton second. This is the impulse of deformation, the first event. And the area under FT graph will give that impulse. So I'm going to compare now with this method. Now let me go for the event 2. Now for the event 2, again the same method. There's a very important problem. They'll undergo deformation. Show some deformation. Again, you'll get confused, sir. What happened that energy? Show some deformation. So this is 2 kg. This is 4 kg. They will have common velocity. Let me call V2. Let me take any one. Again, this is a deformation. Then this will be 2 into 4 minus JD2 is equal to 2 into V2. First conservation of momentum. No? Apply conservation of momentum. 2 into 4 plus 4 into 2 is equal to 2 plus 4 V2. This will be 8, 16, 16 by 6, 16 by 6, 8 by 3 meter per second. Let me apply impulse of deformation. 2 into 4 minus JD2 equal to 2 into V2. 8 minus, this will be 2 into 8 by 3. Anybody value? 8 by 3 only. Now, what is the impulse? What is the basic idea of impulse? Area under FT graph should be impulse, no? So, there's an event 2. It's one of the best problem, really one of the best problem. Now, which is the graph you can pick up? Area under FT graph is what impulse? And the impulse of deformation is same for both. So, which is the possible graph I can pick up? The third one. But sir, you did only for off. I think that is enough, no? You did only for off, because after the impulse of reformation we didn't do. Elastical is telling for elastic collision what is JD and JR should be equal. Is that okay? So this is the very nice concept. Please try to understand, because for elastic collision what should be the JD and JR should be equal. So look at the area. It's a symmetric graph is given also. Then both the events will have the same area ft graph, because the impulse of deformation again equal to impulse of reformation. If you calculate, you'll get same thing. jr1 equal to again jr2 will come. Therefore, this is the answer what I can pick up. So some graphical questions, you have to be very careful. Practice some numericals with all different things, like two particles they collide, that one, some graphical problems. Then we have seen earlier some 3 pathfinder problems, block penetrating, some friction is acting, then with spring, that one, then with some string. This is what needed for us, the preparation for advanced, mains or Olympiad. Mains, they'll prefer some simple formula based. Advanced Olympiad, anything. Pathfinder questions will help you more for Olympiad than advanced. In advanced, such a lengthy calculation they don't ask. Where calculation should be minimum, they'll ask you. So you have to balance yourself. So you are preparing for advanced and mains, okay, Pathfinder, only few selected problems you do it. Your target is also Olympiad, then you must prefer the Pathfinder. The sequence, the preparation you should do in a very systematic way. Sir, I'm interested only mains advanced, then Pathfinder only selected problems.